So the other day we looked at absolute value equations, and we said what we can't predict is whether the thing inside the absolute value is a positive 8 or a negative 8. Because the absolute value of 8 is 8 and the absolute value of negative 8 is 8. So we can't predict. So what we have to do is account for both cases, the possibility that it's equal to 8, the possibility that it's equal to negative 8. Kind of the way we did that was we talked about how that you copy without the absolute value, and then you recopy, but you change the sign of the number on the right side. So that's the way we looked at that. And of course, then we finished solving, got the two answers, checked both of them because we know there's that possibility for an extraneous or extra root or solution. And so we checked to make sure that everything worked and we could write our answer in the solution set form. And that's what we looked at the other day. Let me also remind you of two very simple things, and that is, actually one simple thing with two examples. And it's just graphing. All it is graphing. Our important number here is -3, right? And in both cases we have equals, so the -3 is included. Because we have it written this way in what I call normal, with a letter on the left, then we just shade to the right the way the inequality symbol is pointing, and we shade to the left, which is the way the inequality symbol is pointing. Just to think at it mentally, you know, x is smaller than -3, so it's that direction. Okay, let's want to remind you that case 1, case 2 stuff for absolute value equations, and we'll remind you about graphing because of what we're going to do today. Today, we're going to solve compound and absolute value inequalities. So we did absolute value equations, that's what that example was just a moment ago, but now we're going to look at absolute value inequalities. So we're going to solve them, solve compound inequalities and solve absolute value inequalities, and we'll see how those kind of connect. A couple of important vocabulary words here: intersection and union. This says compound inequality because I mentioned it there. Two inequalities joined by the word and or. And or. These are conjunctions. These are words that we use to connect things, and we're not. It's not foreign to us. We do it in our vocabulary on a daily basis. And or. I always like to think of it this way. If I say, go get me a basketball and a football, you better bring both, or you have not followed the directions, basketball and football. But if I say, bring me a basketball or a football, if you bring a basketball, I have to be happy. If you bring a football, I have to be happy. And really, if you bring both, I have to be happy. You did what I asked you to do. You did what I asked you to do. So that's where this idea of intersection and union comes in, is depending on the word and or the word or. And intersection is and, union is or. We'll see that and how it connects with this compound inequality graphing that you see in here. Here is an example of an or, which an or is a union. I like to say if you went to Powell Valley or Appalachia, you now go to union. So union is the or, one or the other. It says graph these. So you can see what I did is I took this whole compound inequality here and I broke it down into pieces. The first piece, the part before the word or, the last piece, or the part after the word or, and then the whole thing. Okay. So I've got these three number lines just to help us find this works kind of in a simplistic way. And I've taken those number lines and I put a couple of dotted vertical lines here. And the reason why I did is because you can see here we have two important numbers, 7 and 4. I mean, you can see it, 7 and 4. So 4 goes here and 7 goes here. And of course 4 goes here and 4 goes here. And 7 goes here, and 7 goes here. So I'm really breaking my number line down into 5 pieces. And you're looking at it going, I only see 3, 5 pieces. The part to the left of 4, the part between 4 and 7, the part to the right of 7, 4, and 7. Those are the 5 pieces. And so each of them is going to matter when we look at this in compound form. Let's graph these first two partial pieces, which is super dinky for us because we've done this kind of thing many times. So we graph that, and that's the two parts. Now we're going to do the whole thing, or the union, the or. And so the way we're looking at this, it's got to be on one or the other. So I'm going to ask the question, is the left region shaded on one or the other? Yes. So it gets shaded in our answer. Is the 4 shaded on one or the other? No. It's obviously not shaded here, and here it's open, which means it wasn't shaded, so it does not get shaded on the answer. Is the middle region shaded on one or the other? No, so it does not get shaded here. Is the 7 shaded on one or the other? Yes, so it does get shaded here. Is the right region shaded on one or the other? Of course, so it does get shaded here. And so here's what happens. Any number that I pick, let me pull it up just a little bit further. Any number that I pick in the shaded parts will be true for that statement. It'll either be true for the first part or the second part, or it could be true for both. I don't think any of those will happen in this particular case, but it works. So this is an and. The ands are not necessarily more difficult. You've got to be careful. And it's got to include both. Got to include both. So you can see my important numbers. I've got my 3 number lines. I got my first part, my second part, my whole thing. My 2 important numbers are 2 and 5. Now I know there are other numbers on the number line besides 2 and 5. I just really don't care right now. I mean, as a high school algebra 2 student, I kind of get that. So I don't need to put the 0 up there or the 4 up there. I get it. I know how number lines work. And so I'm just going to leave it like that. And we're going to say not equal to 2, greater than 2, right? Could be equal to 5. Could be less than 5. And so we come then to we got our parts, come to the final, the and, the intersection has to include both. If you're in the intersection, you're on both roads at the same time. So we're in the intersection here, and it has to be on both. Is this shaded on both? No. Doesn't get shaded here. Is this shaded on both? No. So it doesn't get shaded here. Does not get shaded here. Is this shaded on both? Yes. Is 5 shaded on both? Yes. Is the right region shaded on both? No. We are done. So what we know is that anything that's shaded is supposed to work. Anything that is not shaded shouldn't work. So we can try stuff like I can try that 4 that y'all are thinking about. That 4. 4 is greater than 2. Yes, it is. And 4 is less than or equal to 5. Yes, it is. It does both. It satisfies both pieces. So you can check things over here and see that they don't satisfy both pieces. They may satisfy one piece, like over here somewhere is an 8, an 8. And 8 is greater than 2, but it's not smaller than 5. So it doesn't do both. You can see why it's not shaded, because it wasn't supposed to be shaded. Now, that's what this is. That's what I just did. And so the and, both inequalities have to be true to get shaded on the answer number line, or the answer graph. So let's look at this. Here's a compound inequality that is really compound. Like, it's not written in the cute little way that the ones I did were written. Those are just introductory pieces. We see this kind of thing happen a lot, and we see that 10 is less than or equal to 3y minus 2, which is less than 19. So we have this compound thing going on here. Let me just quickly underline that piece and that piece so that you see both pieces or both parts. Now, one of the things that you don't see here is the words and, or. They're missing. And the reason that, or in it being missing, is because we're saying 10 is less than or equal to that, and that's, did you hear me say and? 10 is less than or equal to that, and that, you hear me say and, is less than 19. So, that being said, what we know is that 10 is less than or equal to 3y minus 2, and 3y minus 2 is less than 19. So that's what we're working with. So I'm gonna need to resolve both of those, which is gonna take me some doing. So I like the letter on the left. Little m pointing at the 10. Pop the 2 over. Be an add, be 12. And so I get, I'm just gonna kind of pull this here. I get y is greater than or equal to 4. Okay, and then I have my and. And here, I have 3y, throw my 2 over, 21, so y is less than 7. So that's what I'm working with. That's what I'm working with. So the first part is y is greater than or equal to 4. Second part is y is less than 7. And then the whole thing is that. So my two important numbers are 4 and 7. And I'm going to graph. Could be equal to 4, greater. Can't be equal to 7, less. The and, the stuff that's shaded on both. That's the answer. So if I pick a number here, like 5, okay? I'm just going to pick a 5 right here. Pick 5, just to check. 5. So if I put 5 in here, what is 3 times 5? 15. What is 15 minus 2? 13. Look at that and see if it's true. Is 10 smaller than 13 and 13 smaller than 19? Yes. It's a beautiful thing. Math is great. So this is just the unfolding of that. And you can look at that more in the PowerPoint if you want to. But you can see their graphs look pretty much like ours do, only theirs are neater. But anyway, pretty much the same. So we followed through the same process here. We know this is not the or because this is an and statement, so A is not our answer, period. But we need to work through this, and so I'm just going to go ahead and turn it around. That first part, little n pointing at the 11. And the 2x is greater than or equal to 6. X is greater than or equal to 3. And the other piece here, 2x plus 5 is less than 17. 2x is less than, so the 5 over here makes 12. X is less than 6. So you can see what has to happen. It's bigger than 3, less than 6. Bigger than 3, less than 6. Bigger than 3, less than 6. First of all, who does these two things match? Match this one. Look at it. See the, nope, they match this one. Missed it. Match that one, right? Because it's got the right less than piece. And the right less than piece. Less than 6. Okay. So the answer is D, and you can check the graph, as I said, sometimes they write the right inequality but the wrong graph. But you can check it and see that 3 is less than x and x is less than 6. So you can see x, really x is squeezed between 3 and 6, but it could include the 3 because we have the equal. All right. So we've done that, we're doing that, you can see the answer is D. We've done that, we're doing that, and there's the and, the or, but since we've already done some ors, I'm not gonna work you through that in the slow process. The only thing I'll say on that one is notice they did use set builder notation, so set all x's, that's that, but it's still just the same pieces and parts and stuff that we've been doing. But here's the reason we're here today. This is the dance we're dancing. This is 2 is greater than the absolute value of D. 2 is greater than the absolute value of D. So let me drop this over here. Oh, that wasn't the color I wanted. 2 is greater than absolute value of D. Or I could say D or the absolute value of D is less than 2, right? Little m pointing at the absolute value. Okay, so we have this. And the reason why I started the lesson today with that case 1, case 2 absolute value equation is because we were going to do absolute value inequations or inequalities. And I wanted you to be reminded of case 1, case 2, because it's really what we have here is case 1, case 2. Because we're going to pull this apart and we're going to do the same, almost the same exact way we did the equations. I'm going to copy without the absolute value, right? Copy without the absolute value. I've got a word to put here. I'll deal with that in a second. And then I'm going to recopy, and I'm going to change the sign, Notice that I changed the inequality sign and the sign of the number on the right side. That's how this works. And the only other question is which word goes here, which conjunction, and or. And let's see if I don't have that. Right here it is. Many years ago, I was teaching summer school, and I had some students taking Alg 2 in summer school, and they were struggling with this. How do you remember who goes where? And I developed this little thing that I do, and so I'm just going to do it here, although you can see what it's supposed to be. But to me, the word and just kind of fits in there. And the word or kind of creates a cheerleader megaphone for the Raiders. You're kidding. That is too cool. So that's how I remember it. That's how I remember it. Now, you may be a great memorizer. I'm not a great memorizer, but stuff like that fits and makes sense for me. And so that's how I'm going to deal with it. So we go back to this problem that we're doing, and we've got this sign, and that's the and sign. It's like the D kind of closes it off there. And so this is an and inequality, compound inequality. So now I'm going to graph all the pieces and parts. I've got to graph the D is less than 2. I've got to graph the D is greater than negative 2. And then I'm going to graph the whole thing. Oops, put the wrong symbol in there. The whole thing. So my important numbers are negative 2 and positive 2. I think you know the negative 2 goes on the left when you're looking at a number line. And it's less than 2, so it's not equal, less than. It's greater than negative 2, so it's not equal, greater than. But when you deal with the and, it's got to be on both. And that ends up being that stuff in the middle. So let's pick a number in between negative 2 and 2, like 1, right? Let's look at the original problem, actually the original problem. 1. Is 2 greater than the absolute value of 1? Yes. Yes. We can try others. Let's try one that better not work, like, 5. It better not work. You hear me? It better not work. So put 5 in there. What's the absolute value of 5? 5. 2 is bigger than 5. No, it's not. Good. It wasn't supposed to work. I'm glad it didn't work. And that, folks, is how it works. So it's just the unfolding of those things. And let's look at this problem. First of all, is this an and or an or problem? Because it has that symbol. It's like the Raider megaphone, right? Yep. And me, as an experienced veteran, I look at this and I go, well, I already know that's an and, so that's not my or. That's an or, so And those are just single thingies, so I'm pretty sure it's B answer, and I haven't even done anything. It's kind of lazy, I know. But let's look at it, let's go straight up and let's look at it. And so we've got copy without the absolute value. We already know the word is or. Then recopy, change the sign, change the sign. That's our rule. That's the way we do it. That's the way we do it. It's almost exactly like the equations that we had already done and that we began the day with. So when we look at this problem here, or this answer here, you can see that piece and that piece. And then you can see them graphed here. B is the answer. So this looks a lot like the previous problem, except the sign is the and. Less than is and. And so we've got copy without the absolute value, the conjunction and, recopy, change the sign, change the sign. Okay, we know it's not that one because it doesn't say and. Those two are just singles. I'm pretty sure it's the B answer. Look, is that not that first piece over there? And is that not the second piece? Yeah. And it's the stuff in between -5 and 5. So that's the graph. We could do the 3 graphs and see how that works. Hopefully you can manage that with what you've already seen. So that's sort of the picture we're dealing with here. Now, I want to do this problem. It's probably the last one I do, although there's a lot of other things we could do, and I'll let you experience it a little bit for yourself. But I'm going to do this problem, and because there's a little more work to do. But let's copy without the absolute value. Our word is or. Let's recopy. Change the sign, change the sign. You've got to remember to change the inequality sign and the sign of the number on the right side. If the absolute value is not isolated, I would suggest you isolate it. Okay? So then solving this, we would take the 2 over, be a +2, and then we would divide. Take the 2 over here, we get a -2, and divide with the word or. So we've got the first piece, the second piece, right? And then we've got the whole thing. X is greater than or equal to 3, or X is less than or equal to -1. So my 2 important numbers are -1 and 3. And when I graph, this piece could be equal, shade to the greater direction, could be equal, shade in the less than direction, and then the or says if it's on one or the other. Well, the right region shaded on at least 1, the -1 shaded on at least 1, the middle part is not, the 3 is, and the right region is, and that's how you do it.